So in our first example here, we have 3 logs. Is it possible to put 3 logs together as a single logarithm? Yes, but they would have to all be on the same side to do that. So for this first one, I'm going to show you 2 different techniques. There's a shortcut technique that can be used in this one. And then there is the technique that we looked at before, right? Sometimes if you like steps, you like to follow steps all the time. And if you like to follow these steps, well, then the first step is to write everything as a single logarithm. Would you like to see the shortcut first? Yeah. Okay. So for this one, the shortcut is connected to writing things as a single logarithm. But you just sort of start with, well, I've got a log on the left and I've got 2 logs on the right. I could combine the 2 logs on the right to a single logarithm. And then I would get this. So the left is still log of 6x. And on the right-hand side, I'm adding 2 logs. So what does that mean? I multiply. Put an extra set of brackets here so that we can see all of this is inside the log. Now, the shortcut for this is very similar to the shortcut for solving this question that you did yesterday in your homework, right? Almost all of you did logs first. Took the log of both sides because you were in the groove, right? But what's the shortcut for this one? It's the same base, right? So if the bases are the same, the exponents have to be the same. And you said, oh, so 2x is equal to 1, so x is equal to 1/2. That same idea can be used in logs. Are the bases the same of these logs? Yeah. So if you have the base is the same and one log equal to another log, does it make sense that this has to equal that? Does that make sense? Same kind of idea? So then, yes, for the most part, you won't get questions where the bases aren't the same. Well, we solve it like this all the time if there was a log on both sides. But if we look back at our first example, right, there wasn't a log on this side. Right? You could change 4 to log base 3 of 81, but that's not as easy to do as that method. And so this only happens if all you have is logs and logs on both sides. As soon as I would add a +1 to that side or something like that, you wouldn't be able to use this shortcut, because this shortcut only works if you can write both sides as a single log and they have the same base. So in this case, you will get 6x equals x plus 6 times x minus 1. How do we solve this kind of equation? What kind of equation is this? It's going to be a quadratic. Multiply it all out, okay? 6x equals x squared plus 5x minus 6. And then you have to make one side equal to 0. See if we can factor it, which we can. And we get x is equal to 3 and x is equal to -2. Starting with 3. If you plug in 3, you see you'll get 18 there. That's good. You'll get 9 here. That's okay. You'll get 2 here. That's fine. So 3 is good. If we plug in -2, we get -12 here. We don't have to go any further. We know that this one is extraneous. One thing on the final exam this year is they want you to show for sure that you know that something's extraneous. So they either want you to put an X through it or write a little thing underneath like not possible. They want you to be really clear that you know that that's extraneous. They don't want the following. They don't want you to go, just a check mark on one. Did you forget to check the other one? They're not sure. They don't want you to go, I wrote my both answers there. I did it in my head, only x equals 3 works. They want you to be really explicit to show this one is not possible. Again, whenever we're communicating on our tests or our quizzes, we do want to be as clear as possible. On your quizzes, your explain question this time, far better than your explain question was the time before. The solutions you guys wrote were really, really good. Okay? It's about writing things in words and being clear. And so, same thing here. They're getting really picky on that. Show that you know that that's not a solution. We are going to get our quizzes back, maybe this afternoon. So this is how we would do it with that shortcut. And the shortcut makes sense, doesn't it? Now, sometimes those shortcuts are there, but we're in the groove, right? You're in the groove of solving an equation and you miss it. So what does this question look like if we missed it? So let's do it the way, I don't know if we call it the long cut, if there's a shortcut, but let's do it the steps way where we work to try to solve things and put things as a single log. So if you wanted to put everything as a single log, well, all of your logarithms would have to be on one side. So I'm going to just start by subtracting the log 6x on both sides. And then my other side would equal 0. Another common mistake is when people subtract log 6x to the other side, they don't even write equals 0. You still have to write that it's equal and there's nothing left on the other side. Now, we have log laws for adding and subtracting. And you could put these all together all at once. The positive ones are going to be in the top of your fraction. The negative one is going to be in the bottom of your fraction. And we've succeeded in getting this to a single log. Once it's a single log, you change it to exponential form. What's the base in this one? 10. So it's a common log, so the base is 10. The exponent is 0, and the answer is x plus 6, x minus 1 over 6x. What is 10 to the 0? 1. Now this is a rational equation, meaning that we have x's in the numerator and denominator of a fraction. How do we solve rational equations? What would you do first in this one? Multiply by 6x, right? That gets rid of your fraction. And once you multiply by 6x on both sides, of course on this side they cancel out and we get 6x equals x plus 6, x minus 1. And we have succeeded in getting to that step that we had before. So everything after that would be the same as the left-hand side. So is it a little bit longer? Yes. Is it a ton longer? No. So sometimes you might get 3 logarithms and you won't be able to use that shortcut. Like I said, if there was an extra number on this side, then you wouldn't be able to do that. You'd have to move things over. It only works if you have, after combining both sides to a single log, one log equaling another log with no other numbers. Can I erase this? Okay, so let's look at part B. Again, we don't have logs on both sides this time. So we'll go to our steps. We want to change this to exponential form. We know that we can only do that if we have a single logarithm. Can we put our logs together? Yes. And they're adding, so we would multiply. Now that it's a single logarithm, now we can use our definition of a logarithm and change it to exponential form. The base is exponent. And if I multiply that out, I'm going to get x squared plus 2x. It's a quadratic equation. We make one side equal to 0, so subtract 8 on both sides. Does that factor nice? X minus 2, x plus 4. So we get our answers as x equals 2 and x equals negative 4. So we can see our original equation. We have to plug things in to check. So when I plug in 2 into the original equation, again, we're always plugging things into the original equation because if you plug it in when it's already multiplied, sometimes one negative cancels out with another negative. So we're always checking our original equation. When I plug in 2, here I get 4. That's fine. Here I'd get 2. So we can say that x equals 2 is fine. What happens when I plug in negative 4? I get negative 2 here, so right away I know that this is not possible. I wouldn't have to check the second one, even though it's not possible in the second one again. But I want to point out that if you plugged in negative 4 here, what do you get? You get negative 4 plus 2, negative 2 times negative 4, you get positive 8. So if you check it in the second step, it works. But if you check it in the first step, it doesn't work. The other thing that we're going to see in some of our examples, and some of you will misconstrue what we've learned to think, look at our examples so far. Which number doesn't work? The negative number doesn't work. Which number doesn't work in this one? The negative number. So what happens sometimes with students is they think, oh, if the answer is negative, it doesn't work. That's not always true. I can create an example where a negative number works and a positive number doesn't work. Especially, here I'll do a simple one where I'll get an answer where the negative number works. Oh, I should use a pen that doesn't disappear. There we go. There's a simple one where the answer is going to be negative. It's already a single log, right? If I change it to exponential form, the base is 3, the exponent is 2, the answer is 5 minus x. This isn't hard to solve for. Subtract 5 on both sides, we get 4 equals negative x, so x is equal to negative 4. Checking that one, when you plug negative 4 into your original equation, minus the negative is adding. That means that there's a 9 in there. This is fine. So just because our answer is negative doesn't mean that it's not going to work. You have to plug it in to the original equation to check. That's the key important thing. So I can make an equation where the negative number works and the positive one doesn't. And that usually comes up with a question like this, where it's like 3 minus x inside the log. We can make an equation where you get 2 answers and none of them work. Thank you very much. That was really nice. We can make an equation where we get 2 answers and both of them work. So there's a lot of different variability out there. After example 2, and we're going to take some time to practice these, try 11 and 13 as well.